think should be 3.3. All right, we'll check that after. Get this. All right, 3.4. All right, distance. Okay, if I were to start with the number line, if I were to ask you what is the distance, you got on the number line from 3 to 7, what would that be? What would that be? 3 to 7, what is our distance? Matthew, what would our distance be? 3 to 7. It would be 4, right? Okay, now, how do we get that 4 if we're looking for distance? How did he get 4? What did he do with the numbers? Okay, he subtracted them. Okay, let's say that I did it in reverse order, and we did 3 minus 7. Would it still give you the right answer? What if we switched it up? What would it give me if I did 3 minus 7? It would be negative 4, right? So to find the distance, we subtract, but then we have to take the absolute value. That way I can subtract them either way. All right, so now the distance formula. When you see a triangle, and we can use this, if we're finding the distance in 2 points, we can make a triangle to figure out this distance. Do you know, and this comes from the Pythagorean theorem. You remember the Pythagorean theorem? Yes, ma'am.
A squared plus b squared equals c squared.
Very good. A squared plus b squared is equal to c squared. Now, we just said that when you take the, let me write that. You find distance by subtracting, correct? All right. Now, when we're talking about on the coordinate system, which one is it that moves left to right? Is it x or is it y? What goes right, left to right? We measure x. Good. So to find the distance or the a part, wouldn't we take our x values and if we subtract them, we would get the distance? Correct? All right. So if we're looking at if this is found by finding x1 minus x2, if we're getting given a coordinate, how would we find this distance? Well, this is x. What is this? Up and down is y. So we would find that by doing y1 minus y2. Okay, and really, that's all we're going to do in putting it into find the distance formula. Our a part is x1 minus x2 squared. Our b part is y1 minus y2 squared. And instead of it being c, well, this c is just the distance. It equals distance squared. So we get this from the Pythagorean theorem. Now, one of the definitions that you have to write down is the distance formula. You see that? So that should go into your notes. Okay, distance formula. So now, if we're solving for b or we're solving for c in the Pythagorean theorem, what's the very last step that you did? If you're given numbers and you put them in here, what do you do last? For instance, if you have 3 squared plus 4 squared is equal to c squared, you squared them, we get 9 plus 16 is 25. What's the last thing you do in order to find c, right? You take the square root, okay? So the final part of the distance formula is distance is equal to the square root of that, okay? We're going to use those. So we're going to be given 2 points. We need to put those into the distance formula to solve it. All right, we'll practice doing that. Yes, ma'am.
Isn't it switched from 2 to 1?
The y2 and the y1, it is switched on here, but the thing is, it does not matter the order that you subtract them. So whether I subtract the second one first or I subtract the first one doesn't matter. Because when we subtract it and square it, it's still going to be the same thing. So they do, you're right. They have x2 minus x1, but I'll show you it doesn't matter. It doesn't matter the order it is. So. All right, so let's take a look at example number 1. Okay, they asked you to find the distance between the points -2, 5 and 4, 1. All right, x1 minus x2, what am I going to subtract there? What two numbers am I subtracting? Right? Okay, -2 minus 4. Okay, would it be okay to do 4 minus -2? It would. It doesn't matter. Okay, it doesn't matter the order that you subtract them. Okay, it'll still be the same. Because if I took 4 minus a -2, subtracting a negative become a positive, it would be 6, and 6 squared is
36.
36. -2 minus 4 is,
-6.
and when you square it,
It's 36.
just making sure you get on the video, right?
Oh, yeah.
All right, well, you sounded good, you answered it right, so. All right, so we've got, all right, now what would go in here for this, in those parentheses? What are we subtracting there? Yes?
5 minus 1.
Okay, 5 minus 1, if I do 1 minus 5, is that okay? Yes, it is, because we're squaring it, so it's still gonna be the same thing. All right, so we put those in, we already said, when we square 6, we get 36. When we square 4, we get 16. Okay. Now here's what you have to be careful with. Can we take the square root of 36 and the square root of 16 and then add them?
Yes. No. Yes. No.
We cannot. Okay, square roots are, we do that after, so we've got to add 36 and 16 and then take the square roots.
2.
All right, now when you do that, you get the square root of 52, which is, all right, when you take that, you get approximately 3.61. All right. Okay, midpoint formula. Next formula we're going to have to know, midpoint. All right, if I had a number line here, 4 and 8, and we wanted to find the midpoint between it, you probably could look at it and figure it out. Yes?
It's 7.2.
It's what?
7.2.
Now, where's it? Oh,
Yeah, that's what I
where's
was
the 3.61? That's too small, isn't it?
So that would be more like
That's like half of
10.
it. Isn't it? You got 7.2? I think that must be like an error there. Yeah, that's definitely too small.
That would be like if they had already taken the square roots on the inside, because it would be 6 and 4.
Well, 6 and 4 would be 10.
That,
Or if it's
exactly.
a-
So 3.61 would be about the square root of 10.
I think we must have made a mistake on that. All right, midpoints. Midpoint between 4 and 8. What is in between 4 and 8? That's all midpoint is asking. What number is in between 4 and 8? Cool. 6. All right. Now, any way that I could do that mathematically, 4 and 8, how would I use those numbers to figure out the midpoint?
Divide 8 by 4. Take 2 by 4.
That works, but that shouldn't work every time. Yes?
Subtract and divide by 2.
Okay, subtract and divide by 2, let's try that. 8 minus 4 is 4, divide by 2 is 2. You're close though. You're close, yes.
I was gonna say you can divide 8 by 2, divide 4 by 2, and then add 4 and 2.
No, don't you just
You guys are all close.
take half of each?
Well, let's think about what average is. If you're finding average, for instance, if I had a bunch of points that I scored in basketball, I scored 7, I scored 9, I scored. how do you find average? Isn't average finding the middle, right? Isn't it finding the middle? So if we got 2 points, how do you find the average of 2 points? Yes.
You add both of them and then divide by the same number of points.
You divide, right, but when I'm talking, please don't. Okay, you take the two numbers, you add them, and then you divide by 2. So that's how we find midpoint, okay? Except for we have coordinates now. So we want to find the average of our x coordinates, and we want to find the average of our y coordinates. So the formula would be x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Okay? That'll give us, so when we're given 2 points, that will give us our midpoint. So, example, with example number 2, if we want to find the midpoint between -2, 3, and 1, 5, okay, here's how we would do that. All right, we want to find the middle number in between the two x's. Okay, -2 and 1. We add those up, what do we get? We get -1, but then we divide it by 2, we get -1/2, right? Okay, -2, we add the two x values, divide by 2, so we would get -1 over 2. All right, then what would we get for my y average, or my y midpoint? We've got 3 and 5, which you can probably figure that out. What's in between 3 and 5? In between 3 and 5 is 4, right? 5 plus 3 is 8, divided by 2 would be 4. So we get -1/2 for the midpoint. All right, good. Example number 3. All right, actually, let's go past that one. We'll come back to it. All right, example 4, slope. The slope between 2 points. Slope is what over what? Remember? I told that something over something. Okay, Luby, what is it? Y over x, they both start with R. No. We call rise over run. Remember that? All right. Slope is rise over run. The rise is talking about the, and you said the right variables. What's the rise, Luby? The rise is the y, and the run is the x. Okay, so the formula for this, in M, stands for slope. All right, formula is y2 minus y1. Like I said, the order doesn't matter. You just, in this case, you want to go in the same order over x2 minus x1. All right, now example number 4, the graph is hard to show you, so I'll combine to help you with those. But if you're given 2 points, we just have to use this formula to solve it. Okay, so letter B asks find the slope in between the points 1, -4, and 3, 2. So what is my y2? What number there is the y2?
2.
Okay, it's 2, good. All right, so 2 minus, Eric?
It'd be -4.
Okay, 2 minus -4 over what? Nathan? What's x2? Three minus 1. Okay, good. All right, so x2 is 3, so we do 3 minus 1 for that. All right, what is 2 minus -4? We get with that. Yes, when you subtract a negative, it becomes a positive, so we get 6 over 2. Can we simplify that? Yes. Simplify that to just 3 over 1. So we get a slope of 3. All right, now when you're given a graph of a line, you have to just figure out what those 2 points are to determine the slope. I really can't show you that without a graph here, so I'll go around to help you out with some of those. All right, go ahead and flip to 132. All right, so in your notebook, you need to have written down the distance formula, the midpoint formula, and then these 2 postulates, the parallel slope postulate and the perpendicular slope postulate. All right, for the parallel slope postulate, okay, basically it says that in order for 2, well, let me ask you this first before I go over it. If I draw 2 vertical lines, are they, I'm sorry, they're not vertical. If I draw 2 horizontal lines, are they parallel? Why not? Are horizontal lines parallel?
Yes.
Yes or no? Are 2 horizontal lines parallel, Brian? It depends. Okay, now on, let me be more specific. Is that what you were thinking of too? If the depends on if they're marked or not? Okay, good. But what if they're on, what if they are horizontal on a grid, on a y-axis, and they're both horizontal? Can I say that they're parallel? I can. You don't have to have the arrows on that. You're right if it's just marked or drawn. Okay, so horizontal lines are going to be parallel to each other and vertical lines are going to be parallel to each other, right? Okay, those are 2. And then what about if 2 lines have the same slope? If they had the same slope, would they be parallel? Yes. Okay, for instance, if a line had a slope of 3 over 1, that means we go up, let me draw a grid here. If they had a slope of 3 over 1, that means we go up 1, 2, 3 over 1, like this. If I drew over here, if I went up 1, 2, 3 over 1, now my line's not perfectly proportional, but if they both had a slope of 3, they would be slanting the same direction, wouldn't they? Okay, so if their slopes are the same, they are parallel. All right, there's also a relationship for if they're perpendicular. Anybody from advanced math remember that one? Would the slopes be the same if they're parallel? Or I'm sorry, if they're perpendicular, would they be the same? They're not going to be the same. Okay, one of them, if we draw perpendicular lines, let's draw them slanting. Okay, usually if we go from left to right, and we would go up from left to right with this line, wouldn't we? We would go uphill if we're going from left to right. We call that a positive slope. And if we're going from left to right down, this line would have a negative slope. So we know they're not the same, right? They can't be the same. Would one always be positive and one always be negative if they're perpendicular? Yes, okay, unless you've got vertical and horizontal lines. Okay, the relationship is the product of their slopes is always -1. So if I told you that, if it's perpendicular, if I told you that one line has a slope of 3, if it's perpendicular to it, the other line's going to have a slope that is the opposite sign and the reciprocal of it. So what is the reciprocal of 3? Remember what reciprocal is, just flipping the fraction. So if it's 3 over 1, okay, it would be 1/3, and it's the opposite sign, so that slope would have a slope of -1 over 3. It's always that relationship if it's perpendicular, okay? Negative reciprocals, and that postulate says that. So if I were to multiply these two, would I get -1? I would, when you multiply reciprocals. Okay, let's say that I gave you, here's another one, let's say that we found that the slope was 2/3. Okay, what would the slope be perpendicular to that? If one was 2/3, -3/2, good. Okay, if it's perpendicular, the slopes, one would be 2/3, one would be -3/2. If they had the same slope, we would say that they are what again? If they have the same slope, they are parallel. If they have that relationship, they're perpendicular. If they don't have either, then they're neither parallel or perpendicular. All right, we'll stop there. Homework is going to be 2 through 40 even. And if you would have 3.3 out, I want to check that.
You can go ahead.